Question number 7. A centrifugal pump with the R equal 63.5 millimeters. B2 mean the width of the blade is 10.16 millimeters. Beta 2 is 60 degree. Is pumping kerosene with specific gravity of 0.8. So, and then at rate of 7.57 liter per second. Okay, again here, please make sure that you could convert unit from liter per second into meter cube per second and rotating at 2000 RPM. So the rotational speed here is rotation per minute. Okay, for best design, entry condition determine the theoretical pressure head rise and fluid power. So best design here means there is no whirl velocity. So mean this is the V whirl 1 is equal to 0. So the Euler head could become maximum. Okay, I already explained how the value of V whirl 1 equal to 0 could make Euler head maximum. So this is the question. So and then we could start with the velocity triangle. So it is okay for us to draw the representative velocity triangle, which is the backward. So this is the direction of rotational speed, the omega here. So this is the best condition means if the V whirl 1 is equal to 0. So we could draw the velocity triangle like this. And this is the velocity triangle at the outlet. So it is given in the question that the beta 2 is 60 degree here. So for beta 2 here, it's referred to the angle blade at outlet because the subscript of number 2 here is actually the outlet point. So the angle is 60 degrees. So we draw it like this. Certain people draw it like this one. So both are correct. So it's depend on you, the way you want to show the angle for the blade. So and then we need to draw the velocity triangle, and then we need to calculate the theoretical pressure rise, which is the Euler head. So we could calculate the U2 here, okay, based on this equation, pi dn over 60, and then we could get it is equal to 13.30 meter per second. We also could calculate the value of VF2 according to this equation, and then we could get it is equal to 1.8672 meter per second. And then we could calculate the value of V2 by looking the velocity triangle at the outlet here. So I think you are quite familiar with this equation. Okay, I'm not explain it here. So the value of V2 is 12.222 meter per second. So and then we could calculate the Euler head by using this equation. So this is the normal one. You could refer to previous notes to know how the Euler head are being derived. And I hope you could remember that. That is one of the famous questions for final exam. So and then if we substitute all the value, we could get that the Euler head value here is equal to 16.57 meters. And then we could calculate the power output. So it is quite simple because the equation for power is this one, rho GQH. So because we don't have so much information, so it is okay for us to substitute the value of HE, which is the Euler head, the theoretical head, or the maximum head that can be produced by that pump. So if we substitute in the equation, so it is equal to 984 watt.